This is our car snow clearing drone, MQP.
I'm Matt Bird.
I'm Bailey Joseph.
Hi, my name is Drew Robert.
Hi, I'm Gabriel Rodriguez.
I'm Nick St. George.
Clearing snow off of cars is essential for the safety of the driver of the car and other drivers on the road. However, clearing snow is a time-consuming, labor-intensive task that can be really difficult for some individuals. This project was inspired by a number of existing drone applications, such as clearing ice from wind turbines and the automated spraying of crops in agriculture. The goal of our project was to design, build, and test a drone capable of clearing snow and ice from the windshield of a car. The result was an 11-kilogram drone that is nearly 2 meters across from the outside of each propeller, capable of lifting a 1-gallon payload of de-icing fluid that can be sprayed onto the windshield of a car.
Now that we've overviewed our project, let's dive into our methods and approach. Our objectives broke our project into 5 components: research of relevant material, drone design, prototype testing, a comprehensive drone design summary, and suggestion of future iterations or projects. Our specific goals for the project consist of 2 types of metrics: standards to which we want the drone to perform, and design factors we deemed critical to the drone's success. They each contribute to envisioning a drone that can reliably clear a car's windshield of snow.
We'll talk about the design approach and all of the components that are inside. The center frame is constructed of carbon fiber sheets that hold all of the electronics, as well as a battery tray that sits below the center frame. The landing gear is constructed of carbon fiber tubes held together with 3D printed ABS plastic joints, and the rotor arms are half-meter long carbon fiber octagonal tubes with custom machined aluminum motor mounts at the end to mount the motor and propeller assembly.
The power unit components found on the drone are 4 brushless 190 kV motors, 4 50 amp ESCs, 4 28-inch propellers, and one 22,000 milliamp hour LiPo battery. Some of the flight management components are a Pixhawk flight controller running Pix4, a ground station running Q ground control, and a Tyrannus radio. Some of the auxiliary systems found on the drone are a thermal camera, which hooks up to the Raspberry Pi Zero, and a diaphragm pump for the spraying unit. And here's our wiring overview. You can see the 2 main components being the flight controller and the power distribution board.
Let's talk about how the team analyzed the different components and subsystems. The team performed finite element analysis on the center frame and the rotor arms to ensure that there was minimal deflection and stress concentrations on the elements during flight.
An onboard camera enables the drone to detect the car and how much snow has been cleared from its windshield. Using OpenCV, the infrared images are processed to detect patches of snow and where they are relative to the drone's spraying path.
Now we will discuss our conclusions and accomplishments, including fully building the drone. Based on our design, our team was able to fully assemble the drone and test all the motors, as seen in the photo. By the end of D-term, we hope to get the drone flying. We also provided a number of additional recommendations for future teams on this project. There are a number of additional societal impacts of this project, including cleaning cars at a dealership and cleaning snow and ice off of houses' roofs and off the tops of semi-trucks. We would like to thank our advisors as well as our supporters at WPI Tinkerbox and Hydro Cutter.